In this installment, we're going to look at the situation in the previous installment and graph it. So the first graph we're going to make is a momentum time. So there's our origin. Y-axis is momentum, x-axis is time. We'll be able to read anything about the axes. The slope is delta P over delta T, which is the force. And the area is momentum times time. Kilogram meters per second times seconds. Kilogram meters is not really something that we place a value on. So our situation we had beforehand is we had a momentum of 4 kilogram meters per second. An impulse was imparted to the cart, giving it a momentum of 5, and it occurred over a period of 0.10 seconds. So we had a momentum of 4, and then later we had a momentum of 5. So for some period of time, it's moving along like so. There is a time interval of 0.10 seconds. It takes for it to go from momentum of 4 to a momentum of 5. Now, since this cart was being pushed by someone's hand, we assume that's a constant force. And the slope is force. So a constant force. And that's what this looks like. Steady momentum. An object wants to keep its current velocity. It experiences a force, which causes its momentum to change. Force applied for a period of time. Gives it an impulse, changes its momentum. Now let's shift to the force time graph. So we know where the origin is. The y-axis is force. The x-axis is time. So we can read anything about force and time off the graph. The slope is delta F over delta T. And the area is F times delta T, which is the impulse. So let's connect these two in time by drawing these two vertical lines representing a delta T of 0.10 seconds. Now we know the force was 10. We figured out the force was 10. And that 10 was applied during that 0.10 seconds. There was no force applied as it was moving along because there was no change in momentum. There was no change in momentum afterward. There was just a change in momentum during this interval of time. Now, if we look at the area, this area is the area of a rectangle. It's length times width. And the length, we'll call it the long way, is the average force, and the width is the change. Wait a minute. Oh, so the area is the impulse. Indeed, and the average force, or constant force, was 10, and 0.10 seconds is 1 Newton second. And that was the impulse, 1 Newton second. So these are two graphs describing exactly the same phenomenon, just with two quantities. And that's graphing momentum in time and force in time.